In today's lesson, we're going to add fractions with unlike denominators using models. The big thing about today is knowing that we cannot add things if they aren't the same unit or measurement. Okay, so if I said I have 2 adults and I have 3 adults, how many adults do I have? You could tell me I had 5 adults. But if I said I had 2 adults and I had 2 children, you couldn't tell me. If I had 2 adults and 3 children, you couldn't tell me I had 5 adults. You couldn't tell me I had 5 children. You could instead tell me I had 5 people because we were able to use the same units. Let's go ahead and try to add 1/2, and 1/4. Now, if I have these two that I'm adding, you cannot tell me what my sum is because these are not the same size pieces. In order for me to add the same size these, I need to use the same size pieces. Well, I could replace one of the pieces with some other pieces. So I could replace 1/2 with 1/4 and now with 2/4, and now I have 1, 2, 3/4. I could also cover this with 1/8 pieces because the 1/8 pieces will perfectly cover those pieces. And here I have 1, 2, 3, 4, 5, 6 eighth pieces. But either way, I needed the same size pieces in order for me to add these. What do you notice about 2/8 and 1/4? They're equal. What do you notice about 4/8 and 1/2? Those are equal. 4/8 is the same as 1/2. 1/2 is just this fraction simplified or reduced. Same thing when we had our 4th pieces. Well, 2/4 is equal to 1/2. So we're using equal fractions. We're just changing the size pieces. It still has the same value, as you can see, because it completely is the same size when I put them together like that. So I'm going to go ahead and draw these pieces. 1/2 plus 1/4 equals 3/4 or 6/8. Okay? When we use these models, I noticed I couldn't add them until I replaced them so I had the same size pieces. We can't add them unless we have the same size pieces. Here's 1/3, and I'm going to add that to 1/2. 1/3 plus 1/2. Right now, I can't tell you how much of my whole that covers, how much of my whole that equals. So I'm going to need to find some pieces that will cover this that are the same size. Well, let's see. I have 1/3 there, so can I use a 1/3 piece? No, that one doesn't cover it. I have a 1/4 piece, but the 1/4 piece is still not the same size as that, so that doesn't work. I'm going to try now these 1/6 pieces. let's see, 1/6 and 1/6, that perfectly covers the 1/3. Let's see if I can get the rest of the pieces to perfectly cover the 1/2. And I did. I was able to perfectly cover that 1/2. So 1/3 plus 1/2 gives me 1, 2, 3, 4, 5, 6. Gives me 5, 6. Well, I know that that 1/3 is equal to 2/6. And that 1/2 is equal to 3/6. So when I added them together, 2/6 plus 3/6, I got 5/6. 2/6 plus 3/6, I was able to get 5/6. So I'm going to go ahead and draw my pieces this time again. I'm adding the 1/2 plus the 1/3 and what did we notice when we used these models? When we used these models, I noticed I could replace 1/3 with 2/6 and 1/2 with 3/6. I could add them once the pieces were the same size. This time, let's go ahead and do a different fraction. We're going to do 2/3. 2/3 plus 1/4. 2/3 plus 1/4. Again, I don't know what that total would be. What size pieces do you think I would be able to use just by looking at the size pieces I'm starting with? What size pieces do you think I could use to cover all of those pieces equally and separately? Well, I could use my 12 pieces to cover each third. So this 1/3 is equal to 4/12. This 2/3 is equal to 8/12. And that 1/4 is equal to here's that 1/4 equal to 3/12. That 1/4 is equal to 3/12. Well, how many 12ths do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 12ths. 11 12ths. What did you notice when you looked at these models? When we use these models, what did you notice? I'm going to go ahead and draw this while you're thinking. I have my 2/3. Again, it's not perfect, but it's okay. 2/3 plus my 1/4. What did we notice? When we use these models, I noticed that 4/12 covered each of the 1/3 pieces. This is what I noticed. 4/12 cover the 1/3 pieces. So 8/12 covered the 2/3. 1/4 could be covered with 3/12. When the pieces were the same size, I was able to add them. When the pieces were the same size, I was able to add them. So that brings me to my conclusion here. When are we able to add fractions? When are we able to add fractions? Well, we're able to add fractions when those fractions are the same size pieces. As long as they're the same size pieces, we can add them. Well, what if we start off and they're not the same size pieces? Then we can replace them with other pieces, but not change the value. They're the same value. They just look a little differently, so we can do our addition.